Hello everyone, my name is En Hao. Today I'm excited to share with you our project with focus on developing a logistic regression model. Our goal is to accurately identify fraudulent transactions within a data of credit card transactions from September 2013, significantly among European cardholders. In our project, my responsibility is to apply lasso regression and conduct model evaluation. In our project, we applied lasso regression and its pivotal role in enhancing model prediction accuracy and facilitating feature selection. Lasso regression employs L1 regularization. This technique adds a permanently equal to the absolute value of the coefficient magnitudes to loss function, thereby encouraging specificity in models parameters. We focused on two specific lambda values that are crucial to our study, lambda mean and lambda 1 SC. Lambda mean is approximately value at this, and it is identified as the optimal level of regularization that minimizes the cross-validation error. On the other hand, lambda 1c, which is the estimate to be around 0.0285, is chosen for its balance between simplicity and robustness, even if it means sacrifice some degrees of predictive accuracy. To visually represent our findings, we have prepared a figure that plots the MSE from cross validation against various lambda values on a logistic scale. This plot on instrumental in illustrating the inverse relationship between regularization stress and the model performance. As lambda increase, we observe a reduction in error, signifying improved predictive accuracy. In analyzing the results of our lasso regression model, one of the key observations is the small magnitude of model coefficient. This outcome aligns perfectly with the objective of lasso regression, which aim to simplify the model of reducing the coefficient of less influential prediction towards zero. This not only helps in the feature selection, but also enhancing the model interpretability. Furthermore, the coefficient provides insights to the log odds impact of each predictor on likelihood of a transaction being fraudulent. For instance, the variables such as V1, V3, V5, and V6 emerge as significant predictors but exhibit a negative relationship with the probability of fraud. This means that as the value of this predictor increases, the likelihood of a transaction being fraudulent decreases. In exercising the efficiency of our model, we turn to the RSME. A lower RMSE indicates a closer fit to the data, which is indicate a model's accuracy. Our findings were quite promising. The RMSE for training dataset stood at approximately 0.02848, while for the testing dataset, it was slightly higher than 0.02906. This is low RMSE value suggests that our model achieves a higher level of accuracy in its predictions, fitting the data reasonably well. More importantly, the minimum difference between the training and testing RMSE value speaks volumes about the model's ability to generalize. After fitting our model to training data, we proceed to test its predicted power on using unseen data. In our case, the confusion matrix for the test data revealed some insightful details about our model's performance. Notably, it identified higher numbers of true negatives, which amount to 84,967. This means that our model was especially effective at correctly identifying the legitimate transactions. Additionally, the model correctly identified 52 true positives, which the number of true positives is smaller. It is important to recognize the complexity of accurately detecting fraud due to its rarity and the sophistication of fraud techniques. However, our analysis also uncovered areas for improvement. We observed 87 false negatives. This is a critical area of concern as it means some fraudulent activities could go undetected, potentially lead to the financial losses. Lastly, the model produced a very low number of false positives, only 11. While keeping the false positive low is beneficial to reduce the inconvenience to cardholders. In addition to the confusing metrics, another critical measures of our model performance is the AUC and the RUC curve, particularly obvious our test data. Our model achieves an AUC of 0.9824. This is a noteworthy result as it signifies a very high ability of the model to difference between legitimate transactions and fraudulent ones. An AUC value is close to 1 is indicative of excellent model performance, suggesting that our model has a strong predictive capability in identifying fraud with a higher degree of accuracy. And the conclusion is that based on the analyzed report, we successfully identified key variables that significantly influence the likelihood of a transaction being fraudulent. Furthermore, we developed a logistic regression model that's achieved by an accuracy correctly predicting fraud in 97% of cases. And thank you all for your attention and for the opportunity to share our work with you.